section so that you can post your ideas or questions in Q&A section. We can take it up and our speakers will help you to take you through it. So yeah, let's get started. We have here Saqib and Vandana here. They will be talking about social shopping. As we know that this COVID situation, we cannot go out much for shopping, and also they have something very interesting and unique idea actually. So let's welcome them. Over to you, Saqib and Vandana.
Thanks, Kirti. And good evening, everyone. I'm Saqib, working as a consultant graduate at ThoughtWorks for last 6 months. And we are here today in this call to share our experience and the things that we learned while building a social shopping application at ThoughtWorks Innovation Labs India. So here's how our agenda looks like. We'll talk about the idea first, and then the tools and technologies using which we can turn this idea into a reality. And finally, we have a demo for you to watch. Following that, the Q&A session, as already discussed by Kirti. And just a FYI, you can still post your questions in the Q&A box of Zoom as we move forward. So the idea of building such an application popped up during this pandemic. As we all know, this pandemic has pushed us to use mobile phones and laptops for shopping, and we kind of face a few limitations while shopping products online, such as clothes and cosmetics, right? So, and as we all know, the most preferred way of buying such products is to actually try them on. And we also seek recommendations about the products we want to buy from our family and friends while shopping in real time, as we used to do while going into the real physical shops with our friends and family. But current online shopping platforms do not provide such a kind of experience. So here our application, social shopping, comes into rescue, and it kind of gives you the opportunity to shop and experience these products in a virtual way with your family and friends on a simple video call. And customers can try out the products in different angles, and they get to choose their favorite by talking to their friends on the same platform. Let us take an example of buying a lipstick. As you can see on the top right side of the slide, we have a host, basically the person who is trying to buy a lipstick in the bigger window, and she has invited her friends to recommend or to help her in buying a perfect shade of lipstick, and her friends are appearing in the smaller windows on again on the top right side, top right corner. So as she clicks on any of the color shades given in the palette, the lipstick gets applied on her lips, hence achieving virtual trial. And the guest or the family or the friends that are there in the smaller windows can also see the person while while the lipstick are on her lips. So basically, the user flow for social shopping goes like this. You visit an e-commerce website or an application. You choose a product. You try it virtually, and you start a video call on the same platform. And you invite your friends or family. And finally, based on their recommendations and suggestions, you order it or buy it. I hope there's no question in the Q&A. Is Kirti in the Q&A box? Do we have any question?
No, Saqib, you can go ahead.
Okay, yeah. So it's time to get a bit technical, and let's talk about how we can build such an application. So all we have to do is basically merge three things together in a single application. And those three things are e-commerce, video conferencing, and virtual trial. Now, let us look at the available tools and technologies that we can use to achieve the given use cases. So, to achieve video conferencing, we have tools like Socket.io, WebRTC, then Peer.js, and Kurento Media Server in our bucket. But before jumping onto those texts, let us understand what exactly is needed to be done on a very high level for video conferencing. So, video conferencing can be considered as nothing but sharing of video and voice media in real time among two or more clients, right? Just like we do sharing of simple text in case of chatting application. And in such cases, we require bi-directional mode of communication between the server and the client. And as we all know, HTTP is unidirectional, meaning only the client can send a request to the server. And at this point of time, a connection is made between client and server. And as soon as the server sends a response against that request, the connection terminates. So either we can use long polling, or we can make use of something called as WebSockets to achieve this bidirectional mode of communication. And in case of WebSockets, unlike HTTP, once the connection is made between client and the server, it will not be terminated unless and until either one of them wanted to terminate. And WebSocket is event driven. So if client wants to talk to the server, it can emit an event, and the server can reply to that event. And in a similar fashion, the server can also emit an event, and the client can respond to that event, hence achieving a bi-directional mode of communication between the client and the server. Now that we know to achieve video conferencing, we have to use bi-directional communication, which can be achieved using WebSockets. But for our use case, we'll be making use of WebRTC, which is nothing but web real-time communication, and which internally makes use of WebSockets for its signaling process. And it's quite interesting in a way that it sends media from one client to another without having a need of a server, meaning it sends media from peer to peer directly. But it does require a signaling server, which is used for setting up, controlling, and terminating a connection session between the clients. And there are basically three major jobs of a signaling server, and those jobs includes exchanging of session control, which will determine when the clients are supposed to be connected, closed, and send information. The second job is exchange of IP address and port related information, which is required to identify the end user and where the user is actually located. And the final job is exchange of codecs and media types of the user, which is required to set up the particular resolution and media configuration between the end users. Now, once the connection is made, the direct communication between two peers can be done using a framework called ICE, that is Interactive Connectivity Establishment Framework, which makes use of stun and turn servers for finding the IP addresses. Because if the clients are outside of their local area network, they at times their IP addresses are behind some firewalls and NATs. In those cases, to acquire the IP addresses, we need these stun and turn servers. Uh, now, now, because of this direct media transfer, it actually helps in reducing latency. But due to the absence of a dedicated server, it has got a few disadvantages, particularly for our use case. Since we are doing a process of computer vision on the media stream of the host, we had to do the processing in the browser, which is kind of making it a front-end heavy project. and sometimes it leads to significant delay of video playback, which cannot be tolerated at all. So we had to look for a framework which has a server involved in between the clients to process the media streams. And to discuss about that framework, I'll hand it over to Vandana.
Hello all, I'm G. Vandana. I've been working as a consultant graduate in ThoughtWorks for 6 months now. Now, let me tell you another approach, that is Kurento Media Server. That is one of the options that we could use to build a video conferencing app. Now, Kurento Media Server is built on the WebRTC protocol. It gives us various modules that can be plugged in to resemble a media pipeline, which is capable of various processing capabilities such as group communication, video streaming, recording, and encoding. This media pipeline resembles a plug and play kind of architecture where you can put in the modules that you wish based on the use case. To appreciate these pictures more, let us go ahead to the next slide where I will explain you the various tools that KMS gives us for development and come back to this slide. So when we look how Kurento would help us for development, it gives us a client and a server endpoints where the client can be coded in Java, that is Spring Boot, or Node.js. The server is built on C++. The crucial endpoints that are required for building a video conferencing app are the WebRTC endpoint, HTTP post endpoint, and the player endpoint. The picture to the right is the entire toolbox that KMS offers us. That is, includes the protocols, media repositories, computer vision that we will be going to in a while, group communications, and filters. So now let's go back to the previous slide where I can explain how these modules are attached for a particular purpose. In the first picture, that is WebRTC being used as a magic mirror pipeline. Now let us imagine that you are coding an application, which might be hypothetical, where you are the guest and the host, and you want your video stream to apply some kind of a filter on your stream on one side and the other receive it. That is when you would choose the WebRTC as one of the parts of the media pipeline, and along with that the filter. Now the second application is when you receive streams from a CCTV camera. You would like to encode, decode it accordingly, and then stream it on your website. Now looking at this, we can say that Kurento Media Server is advantageous to PeerJS, as in PeerJS the server exists but it just acts as a connection broker. But whereas in Kurento Media Server, the server is capable of various other stuff. Over to the next slide, Saqib. So the last point, right? I have written that you can extend your Kurento Media package to build your filters. Now, what exactly is a filter? We'll look at it going ahead. In our use case, we had to alter the video stream to apply the makeup or the lipstick, right? So filters, in a very basic concept, is altering that video stream to extract what we need. You could use various tools such as augmented reality or computer vision. So this is the principle that all your Snapchat filters, Facebook filters, and your Instagram filters work on. And the main principle that these filters work on is they have a machine learning capability. If they are able to recognize the various features on the object of interest, they have a machine learning library running behind them. This kind of a logic can be coded on the server side or the client side. So what happens when we put this on the server side is that these machine learning libraries are heavy in nature. So when you put that on the client side, these collection of modules have to be loaded every time the application is being loaded in a browser. That could lead to a delay. Next, when I say that you could develop this media element in KMS itself, this kind of machine learning capability is done by the KMS server itself. Now let us dive deep into what filters are.
Vandana, sorry to stop you. There is a question there.
Yeah.
Yeah.
So, yeah, it's about only client server directly connect or admin can control this process.
Okay. So in case of the first tip that we talked about, the WebRTC one, it is very difficult to distinguish the host. Uh, um, so everyone is on a same platform in case of WebRTC. So you cannot really control the processes as a host, because you're not the host actually. Everyone is on the same platform. Like no one is host. Everyone is a participant in that case. But when it comes to KMS, yes, we can distinguish between host, and hence we can give extra capabilities to the host. And this is one of the other disadvantage of using WebRTC over KMS. And that's why actually we are talking about KMS, because we couldn't get our job done with WebRTC. I hope that answers the question. Uh, Maybe Vandana, you can start.
Shall I move ahead?
Yeah, Vandana.
Okay, the last point says that we could develop the filter as a KMS media element. If we go through the documentation that KMS offers us, there is this process called scaffolding, and there is an OpenCV module which has its own OS and everything, in which you can extend it, build your own filter, and then package it inside it. So let's dive deep into what actually these filters are. So the heart of a filter is basically computer vision. In computer vision, to apply a filter, you will have to process the video stream frame by frame. So what is a frame? A frame is nothing but a unit of a video. If we say a video has the quality of 30 fps, we mean that it has 30 frames that run by a second. So to do computer vision, the processing is at the most, in most cases, it is done frame by frame. To do so to apply these various kinds of filters, right, I mentioned that it will read a kind of a machine learning model. So in our case, we use the dlib machine learning library that helps us in identifying the facial landmarks. You can see the translation of the face recognized at the top to facial landmarks at the bottom. So once this dlib facial landmarks receives a face, it is able to give you 68 xy coordinates. So once you have these coordinates, you are able to isolate the part that you need and then apply the color on them. This is a very nude approach. Along with applying color, you will need a few computer vision operations like blurring and blending. Over to the next slide. So to do these kind of filters, to start over, you will need a computer vision library that can be done, that can be coded using TensorFlow, DeepFace, and OpenCV. DeepFace is that popular library that you would have read about, that where a person's face, you can take up the face of a fictional character, and you can speak and imitate their actions. To get started at the very beginning, the OpenCV library is recommended. It has various extensions, that is, it can be coded in Java, C++, or Python. And digging even more deep, I wouldn't tell about more details. So filters are basic mathematical operations that occur on a image. So images are usually considered to be 2-dimensional or 3-dimensional arrays, and mathematical operations like thresholding or convolution happens on these images. When you see simple black and white images, right, so it is simple convolution that is happening on these 2D arrays. Over to you, Saqib.
Yeah, thanks, Vandana. So here's how our final architecture looks like. So for building the e-commerce front end, we have used HTML, CSS, and JavaScript simply, and we haven't implemented the backend of our e-commerce since we have built it on a very POC level. And for video conferencing, we choose KMS over WebRTC because it performed relatively better than the WebRTC for our use case. And for virtualization, and in particular for the lipstick trial, we have used computer vision as discussed by Vandana. Now, but in parallel, we are also trying to achieve t-shirt trial and for nature trial using Blaze Pose, which is a machine learning model for human pose detection, AR Foundation, and Unity Engine. Today, we won't be discussing much about them as they deserve a separate session altogether. But we do have a demo for you to watch. And before that, let us watch the social shopping demo. Vandana.
Saqib, there is one Q&A that can we use the same ML which recognize face to predict face features if some part of it it's not clearly visible or covered? Is it being already done anywhere?
Vandana, would you like to take that question?
Yeah, sure. I said right that it gives us 68 endpoints. So I think we could write some kind of an approximation algorithm that if it detects the nearest points, you could approximate it to be the lip features or something. It would entirely depend upon the use case. So suppose it is detecting the lip points are covered and it is giving you the nose points. We could code it in such a way that take approximate points or uh, yeah, like it would depend on the use case. We could try doing that, yeah, because the lip points are fixed, so we could write some kind of a logic saying if the nose is detected as well, you could kind of approximate it to be the lip. You can see the nose are 32, 33, 34, and 35, 36.
Yeah, thanks, Vandana. Sorry, there is one more actually. It's from Shubha. If we want to buy a sofa for our house, in that case, can we take a picture of a specific place and try virtually?
Uh, if can you come again? Like, if you want to buy a sofa
For
from
our
an
house, in that case, can we take a picture for a specific place and try virtually?
Okay, so yeah, we are actually working on a furniture trial, and we have a demo for you to watch. Probably that might help. That might answer your question, Subha. We have it in our later slides.
Okay, thanks, Saqib. You can go ahead.
Yeah. Okay. Yeah, Vandana.
Yeah, so this is a small demo that we did by hosting this app on local. I'm logging in as the user. I'm giving in the room name. So I have logged in as the host now. Let us assume that this website resembles the e-commerce website where the user is able to try various shades of lipstick. And the user feels that he would need some recommendations from his friends as well, so he sends the link, and their friend joins into the same room. So the host video and the guest video are clearly distinguished here. The host is able to see the guest is able to see the host try on various lipsticks. So if we assume this to be an e-commerce application, it would help in promoting their sales, since many more people are now able to like and share this product, and it would help in the chain of marketing.
Thank you, Vandana. And now, as promised, let us watch the furniture trial and the t-shirt trial demos. At first, we have a furniture trial demo, and we have a question around that as well. So hopefully, it will answer the question as well. So let's say we want to buy this chair. We'll select on try virtually, and a camera will open, and you can put the pointer wherever you want to place your furniture and see how it looks on that place. Again, I just wanted to tell that this is a parallel project that is happening, and the video conferencing thing is not merged into this particular project yet. So this was a basic demo of the furniture trial. We can also, if we want to buy a television, we can also like, this is just for a demo purpose though. Now coming down to the t-shirt trial. So this video is recorded when this project was in its initial stage. Now we have done a very good job in this project, but I don't have I don't have the current video of this project now. So this is how the t-shirt trial looks like. Now with this, we have come to our end of presentation, and I'd like to thank our team at Innovation Lab who helped in building this POC. And we're open for the Q&A session. You can use the Q&A box or can raise your hand.
Yeah, so please feel free to ask or post your question so that we can help you to answer. You can use raise hand option or a Q&A so that we can see your question actually.
So just to give reference to the current examples that we have around, right? Imagine that you were buying spectacles on Lenskart by virtually trying them on. So our project, think of our project as an extension to that, where in Lenskart you could invite your friends and family and try those specs along with them on the video call.
Okay, so thanks everyone. Thanks Saqib and Vandana for the wonderful session. Actually, really, it was really informative. Sorry. Yeah. So thank you so much for taking the session. Actually, great work. So we will be sharing a form for all the attendees so that you can share your valuable feedback so that we can improve. And if you have anything, just please add it to the form so that it will help us to grow more actually. So thank you, Saqib, Vandana again. Thanks everyone for all the panelists and all the attendees. Thank you so much.
Yeah, thanks, Krit. Bye.
Thank you.